Welcome, this is 2.7, Linear Inequalities, two variables. When we solve these kind of problems, first off, linear, it does mean that the x and the y will be to the first power. There are an x and a y because it's two variables. And an inequality simply means that we've removed the equal sign and we've put in an inequality, either greater than and equal to, less than and equal to, or less than or greater than. One of those symbols. So our solution, because there's two variables, will always be in the essence of an ordered pair. Okay, you can't have a solution with just one number, you've got to have both. So we come to our first problem. 2x minus 3y is greater than or equal to 6. So the first thing that I tell you to do is plug in for when x is 0 and y is 0 and then one other point and graph it. So it's just like graphing the equality with two variables. So let's plug in when x is 0. We know that it wipes out that. So we have 3y because x being 0, 2 times 0 is nothing. So we have the negative 3y, don't forget the negative, is greater than or equal to 6. Draw our line, divide by the negative 3. Now remember, when you're dividing an inequality by a negative, you flip the sign, so we have y is less than or equal to negative 2. Okay, we'll put negative 2 in there. We don't really worry about the less than or equal to at this point. We're just trying to get the points in here for this. Pretend that it's an equality if you need to. Now we go to y being 0. So we wipe out that negative 3y. 2x greater than or equal to 6. Divide by 2 on each side. And we have x is greater than or equal to 3. Now I just choose another point. And usually I like to choose like 1, something simple. 1 for the x, I have to solve for that y. So if x is 1, 2 times 1 would be 2. 2 minus 3 times what would be greater than or equal to 6. Okay, you can solve it like you have your other problems. 2 is being added, so we subtract 2 from each side. Negative 3y is greater than or equal to 4. And now I divide by negative 3 on each side, and I would get roughly 4/3 negative. Okay? So now I take these points, move these aside just a little bit. Here are my points off that t-chart. It was 0, negative 2, 3, 0, and 1, negative 4/3. And I go ahead and I plot these. So 0, negative 2. That means I'm 0 going left or right, and I just go right down to negative 2. Then I go over to 3, 0. And then at 1, I'm at about negative 4/3, so that's right on the mark. I should get a ruler. Sorry, I don't have one here at home this weekend. So I would draw a line, straight as I can make it. And I ask that you go clear across the graph on these. Now, we need to go back and look. If it was an equals to with the inequality, then we keep the straight line showing that the point can fall on there. Keep the solid line showing the point can fall on there. If it is a greater than or less than without the line, then we dash this line showing that it can't be on there. And when we look back, we see that it does have the equality, so we leave that. Now, the only thing that we need to determine is we need to show that it's greater than So we need to determine, do we shade above it or below it? You can get to where you can just see this with a lot of practice, but until you're there, I want to show you how I do it. I would take the inequality and I would run some test points. So when we put in 0, 0, is it above or below the line? Well, let's see. We plug in the value, 2 times 0 minus 3 times 0 is greater than or equal to 6. Okay, 2 times 0 is 0, minus 0 would be 0. Is 0 greater than or equal to 6? If you say no, then you're correct, it's false. And so 0, because it's false, should not be shaded. So this being 0, 0, we should not shade it. And I say just draw a few lines, because sometimes we have to erase those. Now you might go, but wait, it was greater than or equal to. At this point, until we start isolating the y and moving the x over, you can't really tell by this what's going to happen. And I can show you that in class if you need me to. So it's best to plug in a point and see where it falls. So 0, 0 is above the line, and it was false. So now we plug in 5, 0. So 2 times 5 is 10, minus 3 times 0 would be 0, is greater than or equal to 6. 10 is greater than or equal to 6. So this one comes out true. 5, 0. 1, 2, 3, 4, 5. It's below the line. Okay? It's below the line. So we can see that shading below the line would be true for this. We'll just keep going with these points real quick. 0, 3. 2 times 0 is 0. 3 times 3 would be a negative 9. Is greater than or equal to 6. Is negative 9 greater than or equal to? False. Now let's graph it. 0, 3. 0, 3. That's above the line. 4, 2. 4 times 2 is 8. 2 times 3 is 6. 8 minus 6 is 2. 2 is not greater than 6. So we go to 4, 1, 2, 3, 4, 2. That one happens to be above as well. Now we have our last one here. 6 times 2 is 12. Minus 1 times 3 is 3. It's greater than or equal to 6. 12 minus 3 is 9. That is greater than 6, so that one's true. And 6, 1. 1, 2, 3, 4, 5, 6, 1. So that one's below. So you notice the true ones happen to be below. These false ones we can mark out. The true ones are below, so that's where we should be shading. We've got the shading correct. Okay, so at this point, until we're isolating the y, that's how I would shade. Now we go to another problem. The solutions of 2x minus 3y being greater than 6 lie on or below this line. So instead of graphing up, instead of shading up, we would shade below, because the points that make it true are below. Yes, you do need to just plug in points and test them. Okay, now we're coming to another problem. 7x minus y is less than 13. So the first thing, just another review of it, we plug in 0 for x. If we plug in 0, that wipes it out. We find negative y equals 13, or y equals negative 13. Now you notice I did switch it to the equality, because as you notice with the other one, the inequality didn't matter. So y is at negative 13. Okay, now we plug in 0 for y. 7x is equal to 13. X is equal to 13 sevenths. If it had been 14, it would have been 2, so it's 1 6 sevenths. So you can switch that as far as a mixed number so you know where it's at on your graph. Now our last point that I will just choose is I just put in a 1. I like 1s because they make it easy, so 7 times 1 is 7. 7 minus y equals 13. Well, we really need to add 7 plus 6 equals 13. So we know that that has to be a double negative. It would be 7 minus a negative 6, because the two negatives would create the positive. So 1 negative 6. Okay, then we're going to test a point above and below and see how we shade this. So let me just erase what we have here. We'll put in this line. Okay, we have 7x minus y is less than 13. And our points thus far have been 0, negative 13, 1 6 sevenths, 0, and 1 negative 6. And then we're going to have to test points to see if we shade above or below. So let's get these in. 0, remember your first one is x, so it's going left, right, because this is your x, this is your x. So it goes at 0 down to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oops, it's not one mark. Get a different one. There's 13. 1 6 sevenths, so just before the 2, 0. And then 1 negative 6, right there. So that's a very steep line. Now, if you plot the 3 points and they're not collinear, if they're not lined into a line, then you know you've made a mistake on one. That's why we choose 3 points. Okay? So there's our line again in class. Please use rulers. I have them in the cabinet. Now, because there is not the line underneath, because it's just a less than, we already know that it's dashed. So make sure that you dash that line. Now, I might choose as a test point 0, 0 again, because it's off the line. So I plug in 0. 7 times 0 is 0, minus 0 is 0. Is 0 less than 13? If you say, yeah, it is, then you shade towards that 0, because it's right there. It's true, and so we shade to that side. Just to test it, I might choose a point out here. Let's choose 10, 0. Now, it should come out false when we plug it in. 7 times 10 would be 70, minus 0 is less than 13. 70 is not less than 13, that is false, so we don't shade that side. Okay, that's the end of this little lesson today. See you in class.